Assalamualaikum everybody. In this presentation video, we are going to talk about microarrays and its various examples and application. Let's go. As per always, we will start off with an introduction.
Definition of microarray: a semiconductor device that is used to detect the DNA makeup of a cell. It contains hundreds of thousands of tiny squares designed to mate with a particular gene. They react to the liquefied cells, pour over it, and are detectable by a laser. Microarrays are helping revolutionize medicine by being able to pinpoint a very specific disease or susceptibility to it, called as biochip microarrays, are commonly known as gene chip. Gene chip is an affirmative trademark.
Let's move on to the history part of the presentation. Microarray is discovered by Stephen Fodor and his research team during the late 80s. Stephen Fodor also happens to be the CEO of Affymetrix of the aforementioned company. The company is also the one to introduce the very first microarray. Now we're moving on to the how microarray works part of the presentation.
Firstly, the sample of abnormal tissue and normal tissue are collected for analysis. mRNA will be isolated from both samples. Both samples will be colored by using fluorescent tag. For healthy cell, it will be colored by green, while the abnormal cell will be colored as red. cDNA bind on the surface of microarray DNA chip in hybridization process. Color or spot will appear based on the expression gene in abnormal cell. Green is gene suppressed, red is strongly expressed, yellow is either suppressed or expressed. Image will appear when scanned with laser.
The following slide is an example of how microarray works. As we can see, there is the preparation of cDNA probe, the preparation of microarray itself, and the results, which is the numerous color spots that can be shown on the computer screen. Next is the examples of analysis of microarray.
Firstly, assessing and determining the difference of gene expression in two cell lines for studying human cancer pattern. Microarray were used to identify the differences in microarray patterns between normal cells and cancerous cells. It can determine the expression of cancer gene in between two types of cell line. Tumor-originated cell line USCC903 will show green color, while its derivative non-tumor-originated cell line USCC903 plus C will show the red color.
The following image is an example of the results from microarrays in gene expression.
Second, the detection of amplified and overexpressed gene by using microarrays such as breast cancer study. The gene used are expressed normally by comparing to the reference genes. The technique involves a CGH microarray to detect change in copy number, while cDNA microarray detect the gene expression.
The following image is the example of results from both microarray techniques. The above is the results from the CGH microarray, while below it is the results from the cDNA microarrays. Now, we are moving on to the application of microarray. First is gene expression profiling or genomic fingerprint. It is used to measure the gene expression levels, identify a set of gene markers for specific disease, or used for gene expression profiling. Next is transcription factor binding. This is to determine the binding sites of the transcription factors, otherwise known as the chip, which is known as the chromatin immunoprecipitation on a chip. Thirdly is to use in cancer research. It is used as a platform for testing of large set of genetic samples related to tumor cells. It also helps in the identification of cancer cells and can be used in drug discovery research and to help to classify the tumor cell type. It can also be used to help genetic abnormalities in a wide range of tumor cells. Next is antibiotic treatment. It can be used to identify the genomic of the bacterial DNA as it can provide information related. Last but not least is early detection of oral precancerous lesions. Microarray can be used to identify the gene expression analysis of the oral cancer. It can also be used as an early detection of the cancer for prevention.